Thanks, everybody. Can everybody hear me okay? Yeah, it sounds good. Well, it's great to be here in Denver. Sunny day, and we're going to talk about IPv6 here indoors, so that feels great. Some background on me. I'm going to talk about how our path to going IPv6 only at T-Mobile. I was born and raised in Sweden. I moved to the US in 2007. In 2009, I remember attending an ARIN conference in San Antonio. I lived in Dallas at that time, and I met with Stan Barber, who some of you guys might be familiar with, and we were talking about the deployment of IPv4 versus IPv6 in the Europe and versus US, and kind of came to the conclusion that we're a little behind here in the US, and maybe we should do something. So we founded the Texas IPv6 Task Force back in 2009. We were inspired by the Rocky Mountain Task Force here in Denver, who, by the way, they're a sponsor, and there's some events going on tonight if anybody's up for a free beer, anybody who's doing IPv6. Nevertheless, I started work for a company called Secure64, also based here in Denver, a DNS company, and one day this sales guy comes into my office and says, "Hey, you got to talk to this guy Cameron at T-Mobile. He's talking about DNS64, NAT64, IPv6. I have no idea what he's talking about. So I know you're into IPv6, so why don't you give him a call?" So I did, and Cameron, who's still with T-Mobile, who's a good friend and somebody I work very closely with, he convinced me that DNS64, NAT64 was the right path for a mobile service provider to take to transition to IPv6. And we actually, Secure64 at that point became partners of T-Mobile, and we had the first commercial DNS64 platform. Anyway, fast forward a couple of years, I worked for Microsoft doing DNS for them for a while, and then about 2 years ago, this opportunity showed up to lead the architectural group within T-Mobile, so I jumped on that. And end of 2016, when I started, one of the first things Cameron said was, "By the way, we're turning off IPv4 on our iPhones here shortly, so that might be something you want to look into and dig into." So it's kind of cool to have that full circle, first working as a vendor, and now kind of have the first-hand view of what we're trying to accomplish and why we're moving to IPv6. If you want to reach me, here's my T-Mobile email address and Twitter, LinkedIn, and so forth. Or feel free to find me in the corridors here lately after this talk. So I'm going to talk about our journey to become IPv4 independent. I'm going to have a little bit of talking about retries, returns, and happy eyeballs and how that is affecting our network. I've been doing a little bit of research there lately. And then give you guys a background for those who doesn't know NAT64, DNS64, and some of the technologies we are using like prefix discovery and 464 XLAT. And then talk about application level fallback to IPv4 and what that is, and then some best practices and some learnings that I've had from removing IPv4 from our network. So our customer base is pretty easy to deal with compared to perhaps a wired service provider where there's Nest thermostats and all kinds of stuff. The bulk of our customer base is either Android handsets or Apple devices. And Android, starting from 4.3 and onwards, have had support for IPv6 plus 464 XLAT. And that's when we decided to turn on IPv6 on these Android handsets. And for Apple, in 2015 at their developer conference, they announced that starting June 1st, 2016, any application within the application store needs to be not only working on a v6 like a dual stack environment, but actually must support IPv6 only networking. So it's been tremendously helpful for us to have those two giants behind us also helping us pushing the transition to IPv6. And just a quick survey, how many of you guys are T-Mobile customers in here? Raise a hand. And how many of you guys have a iPhone? So I don't know if you guys are aware, but you're actually having a v6 only experience today, right? So we have about, give or take 10 million iPhones in our network, and there's no IPv4 interface. If you look at the interface, you turn off Wi-Fi and you look at your interfaces, there is no IPv4 interfaces there, only IPv6. So that's a pretty cool accomplishment, in my opinion. And I mean, this is stuff that's ready. This is nothing we're going to turn on a year from now, 2 years from now. This is now, right now. We've had it on for a year and a half. It works, right? And we've really reached a utopia that I think we all talked about we have been able to move clients to a new IP protocol without even them probably knowing that they moved to an IPv6 only experience, and we turn off IPv4 on them. So it's been a long journey, starting with Android 4.3 somewhere around 2013. We've had talks similar to this talk several times, starting in beginning of 2014, Apricot 37, where we could announce, based on the world IPv6 launch, that we had 16% of our customer base were preferring IPv6 over IPv4 outbound from our AS. And then from there, we've had several talks, as you guys can see, and we've made steady progress. It's tapering off a little bit here at the end. As we're getting close to 100%, obviously, it's a little harder, and there's more corner cases that we need to take into account. But as you can see, it's a good, steady progress. And today, based on the World IPv6 launch.org website, today, some 94% of our traffic is, or 94% of our handsets, I should say, or they're preferring IPv6 over IPv4 going out from our AS. So that's a pretty remarkable accomplishment. And can you guys turn on the clock here so I know how much time I have left? That would be great. So that's a pretty remarkable accomplishment. At this point, you might want to look into, like, what's that remaining 6%? What kind of corner cases are we, like, how's the bottom of the barrel looking here in terms of getting to 100%? And, I think we're kind of the first service provider really pushing, closer, over 90% here, that, we can look at that and see what's going on. If you look at the World IPv6 launch, there's, a big bunch of companies in there. They're doing a lot of good stuff on IPv6. I think everybody is transitioning one way or another. I think on the wireless side of things is us. Verizon Wireless is doing a great job. They have a good adoption rate as well. And then Reliance in India, who's a new entrance to market, and they could kind of go directly into IPv6. So looking at the remaining 6% and zooming in, I think it's 5 categories that is mostly contributing to the remaining 6%. We do have our enterprise clients. We have not migrated our enterprise clients to IPv6 or dual stack yet. The guests are dual stack. So if you're ever going to visit a T-Mobile campus, then if you connect to the guest, you're actually using NAT64 and DNS64 and those technologies that we're using for our handsets, and you're using those for your experience there. But we do have the guests are dual stacked. So if there's an IPv4 literal or something like that coming up, and you have that emergency IPv4 connectivity as well. And more on that later on how DNS64 and NAT64 works. There's also some really old handsets. So Android handsets, for example, before 4.3, they are not capable, or they're capable dual stack, but they're not turned on in our network. So if you look at this link from developer.android.com, you can see it's about the worldwide population of these types of handsets and tablets that are this old is about 4%. So that's measured who is actually going to the App Store to download any new applications. So about 4%. I think that since that's a worldwide number, I think the number in our network might be a little lower. Typically, your primary device is your phone, and you might want to upgrade that a little bit more often. You might have an older tablet or something in your home that might not be upgraded as often, and you're using a little longer. So I think in our network, it might be less than 4%. And also, if you're a power user, you probably upgraded your phone at some point. So most of the connections we're seeing outbound, are coming from power users that are browsing the internet a lot. So they probably have a newer handset. So maybe a couple of percent or something could still constitute, old phones that are not being upgraded. And this is hard for us to do anything. We just have to wait them out, and at some point they'll, buy a new phone, and that old grandma, she'll pass away, and, at some point we'll get to no old handsets. But they're still, I'm surprised because we're talking about like Samsung Galaxy S2. That's a good example of a phone that's, not supporting Android 4.3. So it's pretty old stuff. Another thing that could contribute a little bit to this is retries over IPv4 for one or another reason. So think about we have an LTE network, you're an Uber driver or something, you're using Google Maps or some other application, you drive into a tunnel, you might get some connectivity issues. As you drive out of the tunnel, Happy Eyeballs kicks in and you get a V4 connectivity. And then the question becomes, do you stay now on V4 or do you move back to IPv6? There could be a little bit of this. You know, I'm just starting some research on this, and I'll cover that in the next slide, but it's not significant. Tethering is another case. So if you have a phone, you turn it on as a mobile hotspot. Some of our phones is going to expose just V4 to your laptop. Like an iPhone, it'll be a V4 only experience. Whereas others, like I have an LG V30, a fairly new phone, and that's actually dual stack. So if I do tethering with that, I get a dual stack experience. So there's some corner cases there. Maybe 1 to 2% I would estimate in that category as well. And then the last one is roaming. So our APN roaming protocol is set to IPv4 only. And this is a global setting that we set. So that means that whenever you're roaming to another network, you will be IPv4 back to us and then out to the internet from there. So since it's a global setting, we need to make sure that all the service providers in the world can handle V6 before we turn it on. So it's a little unfortunate that this is a global setting for us. And this is not only for international roaming, you know, Canada, Mexico, Europe, and so forth, but we also have roaming partners in areas where we don't have a lot of connectivity. So like if you drive up north here a couple of hours into Wyoming, you're probably going to find some spots where we don't have coverage, but we're partnering with some local provider and they have coverage. And in that case, you'll also be tunneled back to us via IPv4. So this is probably a 1 to 2% as well. And as we build out our coverage and we become less dependent on those national roaming partners, this will actually burn down this category. But the international roaming, at some point, we will have to make a decision if we want to turn that on and go V6. So don't go to Mexico, Canada, or Europe for vacation this summer. If you can stay in the US where you have T-Mobile coverage, or maybe Puerto Rico is a good alternative for you, then that would be good because then we keep these statistics high. Sweden is, unfortunately, that'll be international roaming, so you're screwed. But you can watch the game on Wednesday. We're playing Mexico, 5 a.m. in the morning, or 6 a.m. I guess here. Anyway, back to IPv6. So there's Happy Eyeballs has been out for a while. The whole idea is that if IPv6 connectivity is bad for one another reason, you should move over to IPv4. So there's a great site that you can check your Happy Eyeballs, the he.test-ipv6.com, and it's like a JavaScript that every 5 seconds retries, and you can see whether you're V4 or V6. And I've been driving around a lot, seeing how can I induce failures here. So and see, do I stay on IPv4 on that case, or am I going to go back to IPv6 after a while? It's been tricky to, in real life, really induce these types of failures. I don't know how common they are. I need to look into this a little bit further. But I also set up a test bed that I just had a kind of a JavaScript just reloading an image every 5 seconds. And then with IP tables, just shut down IPv6 and see how different browsers reacted. And Safari, as well as Google Chrome, are doing a good job, quickly jump over to IPv4, doing the Happy Eyeball thing. And then as I remove that failure and remove that IP tables rule with IPv6, they quickly determine that V6 is good enough again, and they move back to IPv6. So that's what I call the returns, that probably not covered into great length how you should react to IPv6 becoming available again after you're on V4 in the RFCs and the Happy Eyeball RFCs and so forth. But interesting that some of the major browsers are doing a good job there. Others, though, like if you're working on an Edge or an Internet Explorer, if you induce that failure, it's going to fail over and do IPv4. But then even if IPv6 becomes available, again, it's actually not going to fall back into IPv6. So that's an interesting corner case that maybe there's some work here to be done by the browser vendors. Mozilla Firefox on my Android, I couldn't get to work even doing Happy Eyeball and fall over. So once it started to reload this image, it was over V6, I shut it down, and it never actually fell back to IPv4. And I think that is because it's doing the Happy Eyeball in the beginning for that URL or that domain name, and it's not doing happy eyeballs again. It's just assuming that that's going to be good for the entire session, right? Once I had, and similar, if I induced a failure, but I started the browser on IPv4, Firefox never failed back to IPv6, even if IPv6 was available at a later stage. So I think there's some corner cases here that needs to be looked into as we're trying to trend down to 100%. There are some corner cases here in the browsers that probably need some work to make this work a little bit better. So a little bit of a background on how DNS64, NAT64 works. So you have the handset, and the handset is a v6 only handset. So you'll send out a quad A query because there's no v4 interface, so there's no point in sending out any A queries. And that will reach our DNS64 box. If there's a quad A record available, we'll send that back to the client, and the client will take the black path out to the v6 internet. So that's the ideal way of going, because there's no middle machines here that needs to do anything, and it's very convenient for us. The worst case scenario, there's no v6, but there is a v4 address, and in that case, we do a synthetic, we append the prefix, the DNS64 prefix, the 64FF9B in this case, and we convert this from hex to, from octal to hex. And we send that back to the client to trick him into that there is actually an IPv6 address for this website that you're trying to reach. And that entire prefix is routed to our NAT64 gateway. So that packet will now end up in our NAT64 gateway. We can strip off the prefix, and we can send that out on the v4 internet. So we have a ton of these NAT64 gateways in our network. Obviously, they're rather expensive. You want to deploy them in pairs, so there's a failure. So ideally, you know, if you guys can move all your content to IPv6, then we can decom them eventually, right? So we're getting closer and closer, and you know, we'll see how this goes. But please move over to IPv6. And I got to say, you know, the top content providers like the Google, Facebook of the world. They've been doing a tremendous good job of enabling IPv6. So it's some of the smaller CDNs and some other cloud providers that we're seeing some traffic going into being v4 only still. So we're also using 464XLAT. And 464XLAT is also an RFC 6877. Cameron Byrne, he's one of the authors of that. And what it is, it's a kind of a small little piece of code on your Android handset that is exposing an IPv4 address to your Android handset. And worst case scenario, if you encounter like an IPv4 literal, like something embedded into a website, then if you only had v6, you were dead in the water. But this gives you this opportunity to still communicate over v4 by sending it there. The CLAT daemon that's running on your 464XLAT device is now going to do kind of like we're doing with the NAT64 DNS64. It knows the DNS64 prefix, it's going to append it, it's going to create an IPv6 packet, so it can go IPv6 only over our network to the NAT64 gateway, and from there we strip that header and send it out. So that's how it works on Android phones. There's a similar RFC, or a kind of another RFC that we're also using, RFC 7050, discovery of IPv6 prefixes. And this is, instead of hard coding these DNS64, NAT64 prefixes in our network, instead we send a query for IPv4 only.arpa, a quad A query. And from there, we can determine, you can strip off the last 64 bits, and from there the handset can determine what the prefix is, and you start using that. So we don't have to hard code and provision anything. So this is great, and that's how it's working in Android. And Apple device is actually doing something similar when it comes to what I call application level fallback. So if you go to this URL at the bottom there to the developer manual for Apple, they're actually not recommending you, if you create some application, to use the low-level sockets. Instead, they're recommending the stuff in the middle that's kind of in bluish here. So they want you to use what they call NSURL session, which is a higher-level API, and they will take care of all the translation on your behalf and falling back to IPv4 if possible. So the blue stuff here is actually using RFC 7050, sending out these IPv4 only ARPA queries to figure out the prefix. And if you encounter an IPv4 literal, you can actually fall back to IPv4. So here you have a v6 only device with a browser that understands that it's a v6 only device, and it has this backdoor kind of into v4 as needed. So it's kind of cool, you know, I talked about this example where you induce a failure just by adding an IP tables. And it's pretty cool. You sit there with a v6 only Apple device, and then you induce a failure on v6, and then you see all of a sudden v4 traffic coming in from that v6 only device because it's going via that NAT64 device. So pretty cool stuff. The one thing I want to mention here, though, is that you know, we're moving the IPv4 fallback mechanism further up in the stack here as a, you know, as an industry. It used to be a decision that we made from a network perspective. Do we want to dual stack this server or client, or do we want to keep him v4 or want to do v6 only on him? And that's something that then kind of moved into the OS layer with the 464 XLAT. And now the application is making that decision on our behalf. Like when is the SLA on v6 not good enough, and when do I need to fall back into v4? So it's kind of a, you know, an interesting but a little bit scary new path that we're seeing here. And where's this going to end? You know, there's a lot of discussion on DNS over HTTP. You know, who says that the applications, the browser, can't just forward all the DNS records up to their resolver and make decisions up there? And who says they can't just forward everything up to some central cloud and from there just route it out on the internet, right? So something to kind of think about and keep track of. So some of the learnings that I feel we did well, and some things that I want to share is that, you know, obviously invest in IPv6 a little bit. It's like your 401k retirement plan, right? You need to kind of constantly invest and move. You know, we'd done a big investment, which was a very successful investment early on with our handsets, and that panned out really well for us. We're in pretty good shape now, and you know, but we still have ways to go with our internal clients, with data centers. We have what we call NMNet, which is a network management network, where we're running out of RFC 1918 space. So we have still ways to go, but now we can we're working on the traditional upgrade cycles. When something goes end of life, we can work into and enable IPv6 at that point. Determine what sites and applications are important. You know, we did a lot of scanning in advance before we turned off IPv4 on our Apple devices. And some sites are just broken, right? So we did a lot of outreach. There was a credit card issuer here in the US who had a DNS problem with their domain, and we couldn't reach it. The DNS64 kind of derailed, and we couldn't reach that site. And we managed to reach out to them, and they actually fixed it, you know, before we launched, so that was great. Same thing as a university I reached out to that fixed their sites, and some other sites as well. So you know, this has been live for a year and a half now. So if you're a wireless service provider from US or elsewhere, you know, if it works for us, chances are pretty well it's going to work for you too, right? So I don't think we have to be too concerned about turning off IPv4 anymore. It works very good, at least in a wireless environment with Apple and Android handsets. Don't try to fix things with local overrides. You know, one thing that, you know, when we had that card issuer having problems, I was thinking maybe we pop something in our own DNS to just circumvent this problem from happening. I think in general that's probably a bad idea because, you know, especially when we talk about, you know, credit cards and those kinds of things, what happens if they move and somebody else takes their IP address, and, you know, you don't want to be the man in the middle and be liable for that. It's better if actually where the problem is, if they can fix the problem there. And it's, you know, if you have the RFCs, you know, DNS64, NAT64 RFCs, and you can point to the exact, you know, your violation of section 5.3 in this RFC, it's that's good ammunition for them to, you know, to fix on their side. And also pointing to the Apple policy that all the applications today needs to be capable of an IPv6 only experience in the Apple store. So that's a requirement, and, you know, they didn't, you know, some of the applications didn't live up to that requirement, so they have to go fix it on their side. Scan social media. You know, some of this stuff, when you're a large company like a T-Mobile, it might be hard to get through to the people that actually, you know, are working on this. You know, we're a small team that are working deep into this with DNS and so forth. But social media is a great tool to just see if people are having problems. Let's try them on our phones and see if we can reproduce it. And we found some issues that way that we could fix and work together with application providers to fix. And then, don't try to change the world. Maybe keep things in perspective. There's a lot of broken stuff out there already. People are under attack, and there's stuff that doesn't work. They're not RFC compliant. And, don't let a few sites that doesn't work hinder your, deployment and getting off of IPv4. So kind of dive into it would be my suggestion, and, work it out. And it's been useful for us, just diving into this, and at the end of the day, everything worked out fine. So that's my last slide. We have about 4 minutes for questions here. So if anybody wants to. Go ahead. One, two, three. Why don't we wait with you? We go here to the right first, and then we come back to you. IPv4, IPv6, nothing is working. IPv5. Yeah, speak loud.
All right, I'll go ahead and speak now. Matt Peacock from O. Great numbers here. 6% of devices aren't speaking v6 natively at the moment that you pointed out. What's the traffic volume ratio of v6 versus v4?
So the traffic volume ratio is actually is an interesting question. We have a lot of it's actually, more I would say more than 94% of our traffic is v6 at this point, right? Because most of the main content, if you think about, Oath or Yahoo and Facebook and Google and the big content provider, they're all already there, and 96% of our handsets are already there. So you get this kind of matrix where the traffic is really, really large in terms of IPv6, most of the cases.
Hello. Okay. Great talk.
Thank
Just
you.
one question. Was there any kind of gradual rollout of this change to IPv6, or was it a big switch in a day that you say, yep, let's do it?
Yeah. And you are just
Edward from Spotify.
Okay. It started with Android really, right? So 4.3, it was kind of slow start there, and then Apple provided support at the later stage. So it was kind of a big, it was like a flag day, right? We're turning this on, and then anybody with Android 4.3 is going to have it, right? So it wasn't gradually, but then we've grown gradually because people are changing handsets, they're getting new handsets and those kinds of things. So, alrighty, cool. Any other questions? If not, I want to thank everybody for listening. It's been great, and let me know if you have any more questions. I'm here throughout the day and tomorrow, so thank you very much.